Hello, this is Jason with LMGI. Today we're going to try to solve the mystery of the star-shaped clothes dryer. So my friend asked me to build a drying rack that she found on the internet. And so I built one for her based on the specs in that article. And the first one I made didn't seem to collapse very well, and I wasn't too happy with it, and it kind of bothered me. I thought it was related to slight inaccuracies in my manufacturing, and maybe the compounding of errors due to those inaccuracies. So I decided to model it in Solid Edge to find out what is really going on. Solid Edge has a great capability called drag component, and you can do it with no analysis. You can detect collisions, or you can do so-called physical motion. Physical motion will detect how bodies interact with each other. It does require some compute power, so there's a sensitivity setting. I leave it at default, and I'm going to grab in a freeform manner, kind of the way you might just in the real world. And what I'm going to do is kind of collapse this down, and I keep going. You got to give it a little time to compute, and at some point it stops. And if you see the little hand, it kind of stops. It's because the parts have essentially collided with each other, which is really cool. So this proves that there's something wrong with the design that won't allow it to collapse perfectly. Now in hindsight, after you model this, it becomes clear. And for some people, it may be obvious up front why it doesn't collapse. It simply has to do with the thickness of the material. And another great capability in Solid Edge is if you model your parts in synchronous modeling, you can switch to face priority, which allows me to reach into a part and access the face and any dimensions within it without having to leave my assembly. So this is really nice because it will solve. So my first thing that I tried was to experiment with the spacing. I thought, well, maybe it's just a minute, maybe there's something that doesn't round off properly in the spacing. And then you'll see that when it becomes balanced, 5 inches each way, then it collapses fine, but it only will expand in a linear manner, not a rotating manner, which is no good because this needs to connect to itself like a snake biting its own tail. So that wouldn't work. So then I started looking at, well, I wonder if I can offset the width. And I decided to play with that a little bit. It's 1/2 inch by default, and if I drop it, I noticed that if I drop it down around 425, it starts to look really, really good. So I'll do that. It seems to nest really well. And then if I wanted, and then I was concerned, well, will it actually be able to be expanded out into its circular form? And I kind of wanted to make sure that was possible. So we'll just kind of do that. Just kind of keep coming around and bring that. I'm going to get that kind of close so that the assembly relationship solver will have the closest solution. So I'm using assemble. I'm going to grab, get in a little bit. When you're recording, sometimes the smoothness is not there. So And actually, if you look at this through some mysterious mathematics and geometry, these actually line up perfectly. So that, to me, was very interesting. So this proves that you can make it nest, collapse perfectly flat as well as it can, and then you can also make it still work. And but there's a little problem. This is off center now, which kind of makes it weak on one side. And not only that, but when you assemble it, you have to make sure you assemble it correctly. So what I decided to do was build yet another assembly. And now I modeled this with a different color wood on each side so I could be sure it was assembled insides to insides and so on. And what I'm going to do is jump into this part. And I did this part a little bit differently. I did it in order. I wanted to try something different. I want to double click my protrusion, and my dimension comes from the other side, but I'm going to make this so it'd be 575 instead of 425. 0.575, and we bent that. And if you look down it, you'll see that it's got a slight bend to it. And if you're interested to know how that was done, you can contact, put a comment under the video, and if I get any questions to explain how that was done, I would love to hear that. So there's the mystery of the collapsing clothes dryer. So now you see with the physical motion that collapsed very elegantly and solidly, so it could actually have other use cases in its collapsed state. So there you go. If you have any questions, please post questions in the comment section. If you'd like to know how that part was bent, ask that question in the comment section, and we'll see what happens.